I also have to mute it so that I don't get feedback, sound feedback. There we go. All right, so I'm going to start today to describing how to create a parametric family, a cabinet family. And let me start by showing what we intend to do. This is a Revit project that has a wall-mounted parametric wall cabinet. And this wall cabinet, it's a smart family. It has the ability to display not only different types and sizes, but it also has the ability to display different array number of shelves. In this case, I'm selecting a cabinet. It's mounted on the wall. Every time I change the number of shelves, then the instance changes, and it's an array that repeats. Allow me to add an additional constraint to the cabinet typology. This family also has the ability to change materials. The type properties allow me to select. I'm just going to randomly pick another one. Let's say this green element, and then the type properties of the material will change along with the selected element. Let's do a very quick review of parameter concepts that I'm going to be mentioning throughout the exercise. The first one, remember, instance properties. Instance properties are properties that are unique to an object. And typically, when you select anything in Revit, all the properties you see in the property panel, these are called instance parameters. Instance parameters are unique to an object. An example is the mark value of a door, or the mark value of a window, or the level where something is placed. If you change an instance parameter, it doesn't change it for all the elements of the same type. Then the other type of parameters are the type parameters. And these type parameters are all the properties that are common to elements of the same type. So if you're coming from an AutoCAD background, if you change a type parameter, you change it for every element, all the instances of that type in the project. And when you click the edit type, it will expose the dimensional parameters of that specific type. And so I have the ability to create and duplicate new types. I'm going to create here 30 by 48 by 18 with I don't know, with 4 shelves. And all I need to do is change those parameters. 30 by 48 by 18. And okay. And oops. I guess I didn't type the inches. This is how we create new types based on an existing one, and that is 4 shelves. And so a single definition of a wall cabinet allow me to create multiple types of multiple different types that can serve your casework plans. And so let's going to see the process of creating something like this from scratch. And here we're going to explore the process of nesting families inside another one. So So in the order of, just to explain the process, we're going to start by creating the shelf. That's one unit of a shelf, the one that is inside of these cabinets. Then we're going to create a door. It's one leaf of the door, and then we're going to get mirror to create the other one. Then we're going to create the pool as a separate family. The pool is locked and aligned to the door frame. And then we create the assemble of the cabinet. We combine all these elements inside a cabinet family. We create an array of the shelf that is driven by the shelf spacing and the location of the last shelf. And then we load this into a project and we assign the materials. So that's in a nutshell the process. I'm going to go a little faster because I'm just looking at the clock. But all these components are already provided to you in the Google Drive. If you want to do this with me, feel free to do so. But you can wait until I get to the cabinet when we assemble everything and we connect all the different elements. As I may go a little faster, right? Or if you fall behind, just go ahead and grab the family that I have posted in Google Drive. So
can I ask you a question?
Yes.
I know for myself, but I think that there are some of us that have not done families before. Are we approaching this from like the very beginner level, or are you assuming that we already know how to do families and all the family concepts and terms?
Okay, so let's do a poll.
Yeah.
Who has never built a family before? A Revit family. And you can just raise your hand in your screen or let me know. Okay, so it seems like we have a lot of beginners here. Okay, let's okay, I guess then this is going to bleed over the next one. Let me grab my PowerPoint about families.
Because I think that would make a difference on how good we follow you.
Yeah.
How well we follow you.
Give me a second. Where is Okay, let's do the basics then. All right. Here goes a bit of the intro. So in the let's define what is a family. A family, it's a collection of objects that share the same parameters of the same properties, and they have a very similar physical representation. There are three types of family in the Revit world. We have something called system family. System families are representation of assemblies whose boundaries are not unitized. For example, walls, floors, roofs, stairs, ceilings. Those are system families, and a system family means that they cannot be loaded into a project as an external file. I think the most common one is walls. If you're using Revit, you know that a wall cannot be loaded as an RFA. You'll have to copy paste between projects in order to share it, or you can have to transfer the project settings from one project to another in order to transfer system families. Another type of family are the component families. And those are unitized representation of assemblies that are saved into your network into a library of components. The most typical ones are doors, windows, casework, fixture, furniture, plants. You can load them from the load family button. And probably on your company, you already have your library of components. There's one that comes out of the box. There's plenty of resources online to download components. So if you're in need of using a specific type of family, then you have to dig into your library to find it if it's there. If it's not there, then find it in an external provider online, which has its risks, and I can talk about it later, or you can build it from scratch. And what we're going to start doing now is to build a family from scratch. And then the third part of family is called in-place families. And in-place families, and I'm not, this is a little cut, I don't know why, are elements that are unique into a project. Those are families that are created on the fly. They only live inside a specific project. They are intended to represent a single instance. But it's like a family created within the project environment. So what I'm going to show you to do now is how to create a component family from scratch. To create system families, you basically just duplicate a type and change the parameter values. I hope you know how to do that. And then in-place families are rarely used. These are unique conditions on the fly when you're in a rush trying to get something done. I don't recommend using them because you cannot share them easily. So what we're going to do now, it's a component family made of components. And so these components inside another components are called nested families. All right, let's see something else. When you start a new family, you use a different part of the user interface. You start with the family creator. And when you create a new family, you have to choose the appropriate category of the object you're going to create. The imperial template families, the family templates are listed under in the create new family user interface. And these are just a representation of the pre-defined. Each category of Revit has a predefined set of parameters, which are called built-in parameters or family parameters that allow us to create a consistent set of category representation. There are different types of templates. You have casework templates, profile templates, generic templates. And I'm going to show you also how you can change a category of one of. You can start a family with the generic templates and make it specific to another category. The family editor, it's a different interface, allow us to create forms or shapes using these 3D tools or the form tools. So it has extrusions, blends, revolves, sweeps, sweep blends, and the equivalent in void form. And the combination of forms allows us to create basically anything in the 3D space. It also has ways to annotate the family, and those tools are visible in the family creator. Now, as far as the process, I'm going to very quickly go over all the steps. And this is for a component family. Pick the appropriate family category. So when we start the family editor, we browse for the specific RFT. The RFT so you know RFT equals Revit family template. And you can create new RFTs if you consistently creating a specific type of family, you can just save it in the same location of this repository. But we start by selecting the appropriate template. Then the next step is to build the skeleton of a family. And the skeleton of a family define the work planes that define the outer envelope of a family. These reference planes act like the skeleton of a family. You can name reference planes to disclose them in during your modeling process. After creating the skeleton, and again, a lot of this process needs to be it's the response to the question, and what is the purpose of the family? So if the purpose of the family is just to have a single representation, maybe you don't need to spend a lot of time thinking or engineering it. If the purpose of the family is to have a collection of objects that are parametrically and dynamically created, then we need to put a little more thought about how these families need to be structured. So it's a good idea to sketch it in a piece of paper and define what are the behaviors that the family is expected to have, and the degree of representation and granular information that the family needs to contain. But in a fully parametric family, we add reference planes as skeleton, we add dimensions, and these dimensions are converted into labels, or they are converted into parameters. And so a parameter, it's a property of the object that's going to be accessed via the type or instance properties. Changing the value of a parameter allow me to create different variation of the same theme and save them under different family types. So when I say family types, we have a family which is a collection of objects with the same properties. And then the members of the families are called family types. And so you can have families with one type, or you can have families with dozens of types. An example, circular columns. Circular columns, they all have the same shape. They have similar parameters, but then the variation of the diameter generate different members of the family. And then extreme examples of families are the structural steel columns that have hundreds and hundreds of different types that reflect the different ASC profiles. And we use, and Revit has a way to deal with those type of families. After we create and assign parameters, we flex the family, and flexing the family means to change the parameter value and see how the parameter flexes, how the family change in the 3D environment. Flexing the family is like quality control of the families, making sure that the intelligence that you're putting into the object is actually correct and that it's actually working. You have to flex the family multiple times in the process. So this is not technically a strict sequence, but flexing the family is going to happen multiple times as you create a family. Then other steps is we add symbolic line work. There are examples of families that have representational symbolic line work embedded. And what that means is that these symbolic lines are only visible in projection views. When you create an elevation or a section or a floor plan, these symbolic lines are visible. In the case of the cabinets that we were going to create, the dashed line that appears to represent the shelf from an elevation, that's actually a symbolic line work. That symbolic line work does not display in 3D. And it's only visible when in the projection view that you decide that you choose to assign it. Symbolic lines are two-dimensional lines that usually are locked with the reference plane so that they remain associated with the parametric activities of the family. And so after all this work, then we start filling the framework with 3D solids. And we use the solid modeler tools inside the family editor to create extrusion, revolves, sweeps, and voids to represent the final family. We need to make sure that we pick the appropriate reference plane that hosts this solid. We have also the options to assign 3D geometry to subcategories. And then we create additional visibility parameters or material parameters that will allow us to control the behaviors and properties of this family. Additional parameters, for example, are frame materials or leg materials. If you want to display elements, if you want to provide the user the ability to switch components of the family, make it visible or not, you can create yes, no parameters. You can also add formulas if needed. Then we assign the visibility settings of the 3D geometry. And what this means is now that I have this 3D geometry existing, what parts can I have the ability to control the visibility in a specific type of views. I'll give you for an example. In the case of this cabinet, we have doors. Obviously, these doors, I want them to be visible in an elevation view, but maybe I don't want to see them in a floor plan because in floor plan, I just want to see a simple rectangular representation. And so the nested component in the family, it's automatically, it's disabled to be seen in a floor plan, but it's enabled to be seen in elevation views. The last few steps in the process is continue flexing the family, checking that the parameters are working. And once everything's working, we create new types. New types are family members. And as you add new family members, you can create new values, load them into the project, continue flexing them, and then test it into an actual project environment where you can actually see whether the family works or not. So I gave you 13 steps. Not every family requires the 13 steps. This is an attempt to rationalize what it would take to create a fully parametric family. And the cabinet, I was going to show you how I was going to, the tutorial of the cabinet today was going to display that process. Any comment about this? And I went super fast, I know. I can make this slide deck available to you guys if you needed to. Yes, Holman.
I think I understand the general concept of families. To me, this is really the first time I'm being introduced to them. So probably going to have questions along the way. But one of the first questions is this whole idea. So the family can be created from scratch within the model, correct? Can you? Because so the only scenario I've seen, and I think it was a way to deal with having only LT, was that we've taken other families and modified those to create new ones. But as a general concept in learning the software, one question is, can these be created from scratch within the family, or is that only in the Pro version? I think that's the main question.
No, Revit LT has the family editor. Let me just pull this here.
The only thing we can't do in LT is in-place families.
You don't have the family editor?
But we have that. We can edit families, actual RFAs, but not. We can't create an in-place family in a project. There is no in-place tool. You have to actually copy an in-place family from another project, put it into yours, change its work plane and stuff, and then manipulate it from there. That's the only way Light will let you do an in-place family if you take it and copy clip it from another project.
Yeah, and
that's just a fix.
Yeah, I don't know if it's your experience, Jeff, but I usually don't encourage to create in-place families because they are difficult to track, schedule, and control across different projects. It's just, even in the Pro version, I wouldn't spend a lot of time creating them.
Right.
Yeah. But the family creator, it's available in Revit LT, and we can create new components from scratch from this user interface. Any other question before we start the exercise? And I guess yeah, I'm gonna have to extend this to the next class as well. Okay, let's go through the process, and I'm actually going to use this as a footprint to define our journey and creating a new family. So we define first the category. So we're going to create a new wall cabinet from scratch, and I'm going to use a family template that it's a wall hosted family. Wall hosted families are families that use a wall as a host. So I'm going to start a new family, and this should automatically connect you to the family templates folder. If you don't have this, that means that your installation might be a little incomplete. Can I get a nod if you have these family templates? Yes, okay. And then you go into the English Imperial and find, these are all the different RFTs. And we're going to start with a wall-based cabinet. And so there's a family template called casework wall base. There are other templates I'm going to use as well. I'm going to use the generic model. And I'm also going to use just the casework. So let me get back to this. I'm going to start with just the casework one for the components, and then I'm going to go back and use wall-based. So if you already created the wall-based, just close it, and let's start another one. Let's start the casework family. And this is what the default template looks like. It has a predefined set of views. It has a predefined set of references. And it has a predefined set of parameters. So what you see here are the reference planes. And reference planes are the skeleton of a family. You can build them from scratch, or you can have a head start with this template. These reference planes some of this defines the origin of a family. The origin is the insertion point of a family when you bring it into the project. For example, if you select the reference planes at the center, notice how it has an identity data. The name that you see right here is the name that it will be identified at the end of the reference plane. It also have a checkbox that it says defines origin. And the intersection of the two perpendicular work planes with the origin, that is the insertion point. So notice how these particular template doesn't have a horizontal origin. I mean, it tells me that this is the vertical origin, because you see this checkbox here, but the template doesn't tell me where I want the origin. And so on the horizontal one. So I'm going to select this lower, the one that is called front reference plane, and I'm going to make it the origin. And so the intersection of the center reference plane with this horizontal one is going to make this the insertion point. And that's my choice. Well, on your end, you can choose to make this the origin, make this the origin. You pick what's going to be the insertion point. And so when you bring this component into a project, the family is going to be snapped to the cursor of the origin, and then you can place it into the project. That makes sense. These origin reference planes are also pinned. Notice how there's a pin right at the center, which prevents it from moving in the space. And that's a good thing. It also has other reference planes, which are, this is the right reference plane. You can see the name. This is the back. This is the left. Reference planes have names so that they could be easily accessible via snapping in the project. Okay, so we're going to create a shelf, and the shelf is going to have some depth, and it's going to have some width. It's going to be a very, very simple extrusion. And so, give me a second here. Okay, so the framework is already set up for us. So I don't need to do much anything regarding reference planes and dimensions, because they are already provided by the template. And so what I'm going to do is to create a solid. So you go to the Create tab, and we're going to create an extrusion. An extrusion, it's a profile that is extruded perpendicular to your view. And then you select the extrusion button, and then it's going to disclose the temporary this temporary tab, which have the draw tools that allow me to create sketch lines. So a sketch line is a purple line that defines the boundary of an object. And you can use all these tools and modifiers to draw the boundary of a solid. So all I'm going to do is snap to these intersections, and you can see how automatically snaps to these intersections. Make sure you click in those intersections, and then these sketch lines, which are the boundaries of my shelf, are hosted in a work plane, and you can see that in here. And what that means that these lines are actually placed in an elevation defined by a work plane called reference level. And then from this reference level, there's a start and an end extrusion. So from the reference level, I'm going to have extrusion end of 1/2 inch, no, 1 inch. That's the thickness of a shelf. And then in addition to that, yeah, I'm just going to hit apply here, and then hit the green checkbox, which is a way to exit the sketch mode. All right, that's all I needed to do. Let's flex it. Let's see. When you flexing a family, means testing the family or doing quality control to the family to make sure that it's responding to the behaviors you define. And so to flex a family, you access the family type properties. We're going to be using this button all the time, so pay attention where it's located. These are the default values, dimensional values of this cabinet. And I'm going to flex it by giving different values. So I'm going to change this to 1, and you can see how automatically the shelf react to changes in the parameters. So I'm going to leave it at a width of 3, and I'm going to leave the depth as 1. And then this is the shelf. I'm going to switch to the front elevation so that you see how the shelf being defined. So the extrusion starts from level, the reference level. It goes 1 inch perpendicular to the level. I'm not going to make the thickness parametric. I'm going to assume everything in the shelf is 1 inch in thickness, but you have the option to do that on your end. This height parameter, which is defined in the template, is not going to be used, but this is a built-in parameter, and what that means, I cannot delete it. If you select this and hit it, oh, I could. I think it's the other ones. These guys, can I delete? Oh, yes, I can. It's in the other template that there are some parameters that cannot be deleted, but I deleted the height because it's not doing for me anything. And I'm also going to delete the top reference plane. Oh, this is the one I cannot delete. Yeah, this I can delete. I'm just going to leave it there. This is how the shelf looks in 3D. You can give it a shade. And then the other thing I'm going to do is to create a nested material component, material parameter. So all the solids in the family environment have default material. And the material by default is by category. And what that means is going to inherit the properties defined in object style in the project by category. And so one of the things I wanted to show you in this class is the ability to generate concatenated or associate parameters with others. And so this little toggle at the end of a instance parameter it's a way to associate parameters. It allowed me to control the value of the material via other parameter. And the reason this is useful is because materials are best defined in the project environment that it is in the family environment. That's not always the case, but that's usually the preferred workflow. And why is that? Because the project, the amount of materials available in the family are very limited, and you want to make the family as a conduit of project-specific materials. And those projects, those materials are best suited in the project environment than in the family environment. And so I'm going to connect the, give me a second. I have to open the door here. Never mind. All right, so this is the process of connecting associating a parameter with another one. So you hit this toggle, and this allows me to create a new family parameter. And you use this little button in the lower left side that says create new parameter. And this is going to create a new material parameter. I'm going to call this shelf material, shelf underscore material. And you know the difference between type and instance. A type parameter, it's a parameter that is common across all the elements of the same type. An instance parameter is unique to that object, and it will be visible in the project as in the property window. So the shelf material, I just hit OK here. And when I hit OK here, then notice how the value becomes grayed out. And now the value of these material is going to be driven via type. So that is how you concatenate or create associations of parameters. All right, so I'm just going to save this file. Save as. And I'm going to place it in in my C drive. I'm going to create a new folder here called Oxman fall. And let's call this family a shelf. Save it. And our first component is ready to be used. Looking at the clock, it's 7:05, but let me walk you through what we're going to do probably next class. The next component we're going to build is the door and a pool. This is the representation of a cabinet door, and it has two parameters, the width and height. The thickness of this, it's 1 inch. When I switch to a 3D, this is how it looked like. And it has a solid with a embedded glass material, and it has an extrusion that it's 3 inches in thickness all around, with associated parameter as well with the material. And it has a pool, and this pool is a nested family that could be swapped from one type to another one. These are the, I'm just exposing the instance parameter, the type parameters of this door, and the ability to swap family types using a specific type of family format. And so next class, I'm going to show you how to create this from scratch. You're welcome to open the family and start understanding how it works. And then this family, it's saved and it's loaded into the casework family when all the pieces come together. So I'm going to close this family and go back to my project to understand all the pieces. So the first part we did is to create the shelf. Now the width and the depth of these shelves are going to be driven by the parent family, and that's a process of concatenating parameter values. So that's step number one. Step number two is we're going to create the door, and then the door width is going to be half the size of the cabinet width. And then we're going to start looking at how to add formulas into the a cabinet definition. And then we're going to array the shelf using the first and last method and using parameters to control that array. So let's see if you have any questions so far about families. I'm going to capture the discussion on Thursday, and then complete the family, probably the first half of the class. Any questions so far?
I have a question.
Yes.
When you're creating the insertion point or the nested families, do they all have to have the same insertion point, like the back or the front?
No, but you need to be aware of them, because when the nested components are placed on top inside another one, the origin only defines how that element is brought into the other family, but you can always lock the faces of the nested family to other reference planes so that the origin doesn't have an impact on how the element flexes. And so it's really up to you. In this exercise, they don't have the same insertion. For example, the pool, it's in a different work plane. It's going to be placed right in front of that. And so the insertion point is at the center of the pool, whereas the shelf, which we're looking in floor plan, is the back or the front, the front reference plane at the center. And then the cabinet overall, the big assemble or this big family, the insertion point I chose was the center of it. So when I place this into the wall, it looked for, is using the center as an insertion point. But they don't have to coincide.
Thank you.
Another question?
I wasn't sure if you wanted us to be modeling that along with you, or if we're just listening at this point. Are we going to create that from scratch ourselves next time, or or
Yeah,
are we gonna
if you can
use the one
follow,
that's already there?
if you can follow along,
Okay.
if you can follow along, that would be great.
Okay.
If you get lost, I think if you get lost in the process, I always have a component ready for you, so you can always grab it.
Okay.
And the components are in the Google Drive. Yeah. Okay. Let's see. I'm gonna stop sharing. I'm gonna stop the live stream.